Hello, this is Mr. Zanaletto one more time. We're going to go ahead and finish up topic 4. We have a couple of different topics here with regards, there are a couple of different things to cover here. Equivalent statements is the first one we're going to start with. And like I say, that's 4F, equivalent statements. And we're going to have any equivalent statements, it's really two statements that are either both true or both false. So two statements that are either both true or both false. We also sometimes call these truth value buddies. So AKA, also known as truth value buddies, meaning that they both are true or both false. They follow each other. At any given time, they either both will be true or both will be false. The two pairs of these that we find, of the 4 that we had talked about earlier, the conditional statement, if it's true, there's no question then that contrapositive will also be true. And as I said before, if they're both false, if one's false, the other's false. That would also hold true here. So if the conditional statement is true, the contrapositive has to be true. And if the conditional statement is false, then the contrapositive has to be false. It goes the other way as well. Number 2, the second one is the other 2. The converse is the truth. Its truth buddy is the inverse. And more mathematical sounding, those are equivalent statements. Anytime the inverse is false, the converse has to be false. Anytime the converse is true, the inverse has to be true. So that is the equivalent statements. Sort of summarizes that. Biconditional. Another way we can sort of get a little more tricky with regards to these basics. Now, biconditional is a single true statement. So it's a single true statement where both P then Q. If P then Q is true, if the biconditional true is true, then it also implies that if Q then P is true also. So a biconditional statement is one in which it's a single true statement where both if P implies Q is true, then if Q, then P is true. And let's go ahead and further, this is written symbolically, and we talked about that symbol earlier, if you remember. P with a double arrow Q. It's right, it reads, oops, I didn't like Q. I'm sorry. Let's go ahead and get that right. P, double arrow, then Q, and it's red, reads P if and only if Q. looking at this as an example, we would have, a lot of times, these if and only if biconditionals, some of the best examples typically are just, they're related to definitions. So we're going to use the right angle. I am a right angle if and only if my angle measures 90 degrees. My angle measures 90 degrees. Oops. 90 degrees. If you look at that, you can very easily see the I am a right angle is the P part, and if my angle measures 90 degrees is the Q part. And we can easily say if I am a right angle, then my angle measures 90 degrees. That's true. And if my angle measures 90 degrees, then I'm a right angle would also be true. So both of the two things that we said are true would have to be true with the biconditional is true here. And in the end, we could say, again, using our symbols, therefore, in this case, I do have a true biconditional. So looking at this, a single truth statement where both P implies Q is true and Q implies P is true, that is true in this case. We can go ahead and switch P and Q. If Q, then P. If P, then Q. Both hold true, therefore we have a true biconditional statement. And that pretty much does it for notes on topic 4. Thank you.